Hello, and welcome to our program, Astronomy for Everyone. In keeping with our series of deep sky objects, for this month we're going to talk about the deep sky objects of fall. And with me here in the studio are two of our club members and show cast members, Ken Anderson and Steve Whitty. We're going to start out talking about one of the most prominent galaxies that is visible in the sky, one that you can even see with your unaided eye, even from some urban locations. We're going to talk about M31 in Andromeda and its associated galaxies. And Steve, fill us in a bit about these marvelous three galaxies.
Sure. M31 is the large galaxy. In the picture we've got M31, the large sort of diagonal galaxy, and then M32 is the closer in one, and M110 is the further out one underneath. M31, the Andromeda galaxy, or originally it was called the Great Andromeda Nebula, because they didn't know what it was yet. This is a little bit bigger than the Milky Way, our own galaxy, and it is one of the three main galaxies that make up the local group. There are over 500 galaxies, including the little dwarf galaxies, in the local group, but these are the main three ones. I've gotten a really good opportunity to see this in my 10-inch telescope from a dark sky site, and the arms on this galaxy just go on and on and on. So it's 5 times the width of the full moon, and the full moon barely fits in my scope as it is. So I have to just pan and pan and pan and pan in both directions from the center.
Well, Ken, that must mean that the M31 Andromeda galaxy is really quite huge.
It absolutely is, yeah.
Yes, it is. Basically, in real life, it's 200,000 light years across. We see it as 178 minutes by 63 minutes. And it is very bright. It's magnitude 3.4. And all three of these galaxies are only 2.2 million light years away from us. Now, I look at both in my 10-inch and 17.5-inch Dob, and I can see all three galaxies in the same field of view. You know, you want to look at it with your widest eyepiece, like a 40-millimeter 70-degree field of view, or a 30-millimeter E2, or even a 20-millimeter 100-degree field of view. You can see all three galaxies in the same field. Interesting, when you look at the picture, M32 is actually brighter. It's magnitude 8.2, and M110, the larger one, is magnitude 8. But in my 10-inch Dob, I can see 31 and 32 easier, but in my large Dob, M110 and 31 are the two easier ones to see, because M32 just kind of starts looking star-like at the low powers.
Interesting. Now, besides these three, there are a number of other items to look at in the Andromeda galaxy. The next one up would be NGC 7662, also known as Caldwell 22. It's known as the Blue Snowball. Steve?
Yeah, I have not seen this from home. This is not something that I've sought out, and it's a bit tough from a light polluted location like where I live. So you know, it's not that big. Well, actually, it is pretty big. It's half an arc minute. It's a nebula, so we're looking at you know, a cloud of gas, and it's lit up by the central star. But yeah, it is visible. Try to get out to a darker sky site.
Ken, Steve was mentioning some of the sizes there. What are the particulars?
Basically, the Blue Snowball is one of the brighter planetary nebulas. You can actually see the blue in it. That's why it gets its name. But it's magnitude 9. It's 32 minutes across. In full size, it's only 0.8 light years, because it's basically the gas off of one star. And this is like the future of our sun in about 5 billion years. And its distance is 5.6 thousand light years away.
Okay, we've got two other
galaxies.
ones that are also in Andromeda. They're also NGC numbers, 752 and 891. Their Caldwells are C28 and C23. Steve, anything particular about this one?
Oh, sure. The open clusters, generally speaking, are fairly easy to see in relatively small scopes, and it doesn't generally matter that much how bad your light pollution is. Stars, with a little bit of magnification, stars become better contrast to their backgrounds.
They pop right out of the
background. They pop out of the background. Yeah. So these are very nice objects to look at from urban areas.
Okay, I see we've got NGC 891 up there right now. It looks like an edge-on spiral. You can even see the dark dust lane cutting through the center. Is something like that visible in your scope?
Not from home, certainly from a dark sky site, but not from home. The galaxies, there are really only a few galaxies I can see from home. M31 certainly, but this isn't one of them. They have to be very bright, and they have to have what's called high surface brightness, which generally means they have to be bright and compact.
And not as diffuse
not
as some of these
diffuse, right.
other items might be. So Ken, what are the particulars here for these
well,
items?
if you go back to the open cluster, C28 or NGC 752, this one, the first time I saw this one, it was actually at Gladwin, and I had my 2.3 by 40 opera glasses, and I was just scanning the sky, and all of a sudden, what's that bright object? I never remembered seeing that one there.
Mm-hmm.
It's actually closer to Triangulum than even though it's in the Andromeda constellation. But it's magnitude 5.7, and it's 75 minutes across, so it is pretty large, and it's 1.2 thousand light years away from us.
So that's really the closest of the three that we've just been talking about.
And then the other one, the Galaxy, C23, this is the, it's called the Outer Limit Galaxy because it was actually in the Outer Limits series in one of the episodes. It's magnitude 9.9. It's only 12 minutes by 3 minutes across, 110,000 light years in real life diameter, 31 million light years away from us. So.
All right, well, that covers the items that we have in the Andromeda Galaxy. Again, we're covering the items that you can see during the fall. We're going to move over just a little bit to a neighboring constellation known as Triangulum. And one of the prettiest sights that I think is in the sky, it's Messier 33. Some call it the Pinwheel Galaxy, though I know that there are some other galaxies that are also known by that designation. Steve, in your observing, how have you seen this one?
Yeah, sure. This is one of the brighter galaxies that you can see. In fact, it's one of the three biggest galaxies in our local group, and it's not very far away as galaxies go. So you would think that it would be very bright, but it's very diffuse, and so I can't see it from home. I've had to go to dark sky sites to see it. It's got these nice spiral arms that come out, and you can see quite a bit of detail once you get to the dark sky site.
And what are some particulars on this, Ken?
Okay. Well, in M33, just like Steve, when I first started looking with my 10-inch telescope, I had trouble seeing this one. In my 17.5-inch Dob, I had no trouble seeing it. It is magnitude 5.7, so it should be pretty bright, but its size is 62 minutes by 39 minutes, so it is quite large and diffuse.
The light is spread out,
yeah,
more difficult to see.
It's 42,000 light years in real size, but it's only 2.3 million light years away from us. Inside the Pinwheel Galaxy is a real bright nebula. It's one of the few nebulas you can see outside our own galaxy. It's NGC 604, and to see this, you need to have a nebula filter on, and what it appears as, it almost looks like the galaxy has like two cores, except one is further outboard. But I was kind of surprised because I asked one friend, I go, what is that bright object over there? And he said, well, I have a go-to, let's go find out. And we centered it, and it was NGC 604. That's the first time I found out about it.
Looks like a marvelous sight to see in the sky.
Oh,
Steve, have you?
Oh, absolutely.
Yeah.
In fact, it's similar in composition to the Great Orion Nebula, which is, of course, in our galaxy and very much closer. NGC 604 is much, much larger in scale, and it's the gas that makes it up eventually will then form stars. So it's a star-forming region.
Yeah,
And the funny thing is that William Herschel, when he was looking at the Great Orion Nebula, he thought this was the birthplace of stars. It took quite a while to prove that, but that was his first guess. It was pretty funny.
so it's larger in actual size, but in comparative size it's very small.
Very small indeed. Well, we've covered a lot of ground so far in this first part of our program. We're going to take a quick break. If you have any questions, please send them to us. You can see our email address down at the bottom of your screen. And right after the break for Term of the Month, we'll be back with more fall deep sky objects. So don't go away.
The term of the month for September 2012 is supermassive black hole. Kind of a mouthful. What we're talking about is black holes, but sort of on steroids. At the center of our galaxy, there is a black hole that weighs about 4.1 million times the mass of our sun. Now, our sun is a bigger than average star from a mass perspective. In this image, what we've got are the orbital tracks of stars that are orbiting this black hole. And it turns out that when you have two bodies, or you have more bodies that are orbiting each other, you can figure out how much each of them weighs. Well, in this case, you can certainly figure out how much the black hole weighs. And we've been tracking stars using infrared telescopes for like 15 years now, and we've got a good handle on it. On the left there, you can see the orbits of Sedna in red, and the little blue dot up at the top, that's the orbit of Neptune. So these stars are much bigger than our solar system, but they're still kind of comparable. You know, S2 there is orbiting kind of like our solar system. Anyway, 4.1 million times the mass of the sun sounds like it's an awful lot, and it really is, but it is a tiny supermassive black hole by the standards of black holes at the centers of large galaxies. The largest that we know of, the heaviest or the most massive, is in NGC 4889, and it is 21 billion times the mass of the sun. So it's like 5,000 times bigger than our black hole is. There is no upper limit on how big a supermassive black hole can get, or how heavy it can get. Now, stars greater than about 20 times the mass of the sun end their lives in a supernova, and they produce a black hole that is maybe 10 times the mass of the sun, up to perhaps 100 times the mass of the sun. And you can see them, like in an image like this, you get an accretion disk. The accretion disk gets hot due to friction. It glows in X-rays. You can see it. Stars, black holes that are just sort of drifting by themselves in space are pretty much invisible. They're really hard to see. So we don't really see black holes that are bigger than about 100 times the mass of the sun, or less than about 1 million times the mass of the sun. Those are very hard to see in that range. Now, the black hole at the center of the galaxy pulls in gas and dust from the whole galaxy, really, and so it has an accretion disk that's visible, and so on. This year, 2012, a gas cloud was detected approaching our supermassive black hole. So here in this image, you see in red and yellow, you actually see the remnants of this gas cloud, which has been torn apart by the black hole. We think it's going to break up in 2013. It ought to be a great spectacle. So you see the orbits of the stars that we use to figure out how massive the star is, and the positions are where they'll be in from our position in 2021. This process of ingesting an awful lot of gas, this huge gas cloud, should brighten up the black hole, could even make it into more of a quasar, really, really bright with an awesome set of jets coming out the north and the south. And that's the term of the month for September. supermassive black hole.
Welcome back. We're going to continue our tour of the fall sky, deep sky objects, but we're going to shift away from the type of objects that we've been looking at, away from open clusters and galaxies, to a very unique item. This is a star, but it's kind of a special star. Steve, what can you tell our viewers about it?
All right, so this is Mu Cephei. So it's in the constellation Cepheus. That's where the Cephei comes from. And this image, you know, when you look through your telescope, this image doesn't do it justice. This star is red. It's really unusual.
It lives up to its name of the Garnet Star?
It's really, it really does live up to its name. So we're looking at, in this image, we're looking at high magnification, and really stars are dots in a telescope.
Mm-hmm.
So it's really unusual when you see it. It's striking. You know, you've seen red stars before, maybe Betelgeuse or one of the others.
Antares, yep.
Antares, sure. But this is a different color. It's a different red.
Ken, what have you seen about it?
It's known as the most red star in the sky. So, and it's not just a pinpoint; it does twinkle. But that's it for this.
Interesting point to see. Well, we're going to move on to the next constellation, Cassiopeia, the queen of the sky, the queen of Ethiopia in ancient times. And there are two objects in this constellation. The first one is NGC 663. Steve?
So this is an open cluster. It's a relatively bright cluster, magnitude 6.4. So it's visible in really quite small telescopes. And as an open cluster, it's visible from almost anywhere. You know, you could go to downtown Detroit and probably pick it out. So it's it's near some other interesting objects. There's an interesting galaxy nearby. Which one is it? M101, was it?
Anyway. I don't recall. I know there are a number of open clusters in that general region
sure.
of Cassiopeia.
Yeah.
Okay.
So
I'm sorry, Ken.
Yeah, go ahead.
So go back to the image. So 663 is a real unique cluster, and it almost looks like two worms with each one having two eyes on it. So I kind of like this open cluster. It stands out, and it's very close, or you can actually pan to M103, and then the other nice open star cluster in this, which we don't have a picture of, is the Owl cluster, or C13. So basically, these are 9,000 light years away from us.
Okay, so that and NGC 457 that you just mentioned, the Owl, Caldwell 13, are in that same general part of the sky.
Right.
Well, we're going to move on next to another constellation. This is Pegasus, the winged horse. And among the number of things that are interesting to see in this constellation is Messier number 15. Steve,
yeah,
your observation.
Yeah, this is a great globular cluster. It's quite bright. It stands out. You know, when you're looking at an open cluster, sometimes if it's diffuse enough, you can say, "Oh, well, did I get the object or not?" But with a globular cluster, you've got a nice tight core, and it stands out. You go, "Oh, that's not a mistake. I've got it."
Great, Ken.
So M15 is easy to find. It's like a line right off of ENIF, a star off of Pegasus. Its magnitude 6.4, 12 minutes across, 136 light years in true diameter, and it's 39,000 light years away from us. Very bright and real easy to see. It's one of the last objects that you find when you do the Messier objects. It's like the last 5 or so.
As you're waiting for the sun to start to rise and racing to get it done. Our next constellation is Perseus, the great hero of the story of Perseus and Andromeda. And in this constellation is one of the most beautiful objects in the sky that I've ever looked at, and we'll hear from Ken and Steve in just a minute. This is the double cluster, NGC 869 and 884, also known as Caldwell 14. To me, it looks like diamonds on black velvet. Steve?
Oh, absolutely. And this picture doesn't do it justice. And that's not the fault of the photographer or the editor for putting together the image. It's just a whole lot better through a telescope. You've got little pinpoints of light, and you know the clusters like dance out at you. And you just can't capture that on a TV screen. I was at an outreach event one time, and the sky was mostly cloudy, but I managed to spot 2 bright stars for an alignment on my scope, and somebody said, oh, there seems to be a clearing up north. And I punched into my computer, I punched in the double cluster, one of the 2 clusters that make up, they have separate numbers. Anyway, and I swung the telescope around, and despite the fact that I was looking through clouds in the sky, you could see them really quite clearly. I was amazed.
Ken?
Okay. Well, the double cluster is one of the brighter clusters. You can see it naked eye. In binoculars, it looks really good. As you get more and more power, aperture, it does look good, but you want to use your widest eyepieces. So like a 40 millimeter, 7-degree field of view. Fits both of them in there, even down to the 20 millimeter, 100-degree field of view. And with that one, you can actually see the orange stars in your field of view. So the double cluster is 7,000 light years away from us. It's 18 minutes across each of the clusters themselves, and they're 5.3 and 6.1 magnitude each.
Yep, if you have the chance to observe these, please do. We've got a couple of more constellations and items to cover here. The next one is in Cetus, the sea monster, or Cetus the whale. We have NGC 247, also known as Caldwell C62. Steve.
All right, so it's a galaxy. It's going to be very challenging from light polluted areas. You really need to get out into the country to see it. It's really quite nice. It's relatively challenging. It's a fairly bright galaxy as galaxies go, so it's not that bad, but it's going to be fairly challenging. You're going to need some aperture.
Okay, Ken?
It's called the Milkweed C galaxy. It's magnitude 9.2. It's an oval type galaxy, 22 minutes by 7 minutes, and it's 6.8 million light years away from us. It's often overlooked because there is a brighter galaxy just down below it, the C65 or NGC 253, the Sculpture or Silver Coin galaxy. That one's magnitude 7.1, 28 minutes by 7 minutes across, 61,000 light years across, 7.5 million light years away from us. Now that Sculpture galaxy, actually, if we were living on the equator, would rival the Andromeda galaxy. We just don't have the advantage being so far up at the north because
it's too low to the horizon. We're looking through too much of the atmosphere.
So
yeah.
if you can see the star Fomalhaut, you can see that one, and you can also see the Helix galaxy.
Our last, I'm sorry, Ken. Our last constellation is of Aquarius, the water bearer, and this is Messier number 2. Steve?
All right, so this is another tight globular cluster. It's bright as day, and it's really pretty easy to spot. Aquarius is more toward the southern horizon than, you know, it never comes like straight overhead where it's really easy to spot things. But M2 is a very nice cluster, a globular cluster.
Ken?
So you can see in the picture, it's really bright in the center. Magnitude 6.5. It's 11 minutes across, 160 light years across in real life, and it's 50,000 light years away from us. It's a really nice object to look at.
Now, I know you brought a couple of books with you, Ken. In our last minute or so, if you could let our viewers know what help these are.
Sure. These 2 books help you learn what's in the sky for that particular season. Turn Left from Orion from Brother Guy Console Magno, and also Binocular Highlights from Sky and Tell. So this one shows both what they look like in large and small telescopes. This shows what it looks like in binoculars. And for more information on Caldwell objects, you have O'Meara's series. This is the second in the series, Caldwell objects. He also has one for Messier objects, hidden treasures, and secret deep. So you can learn a lot about all these different objects in the sky with this.
Well, I hope you've enjoyed our presentation on fall deep sky objects. If you'd like to get more information, please go to our website. You can see the address down there at the bottom of your screen. And right now we're going to head to What's Up in the night sky, so please don't go away.
What's up in the night sky for September 2012? September starts with an essentially full moon because August had a blue moon. But let's start with the upper right-hand corner, the third quarter. This is the moon after midnight. We have the third quarter on the 8th of September. In the lower left, we have the new moon, which we won't see too much of, on the 15th. In the lower right, we have the first quarter moon. That's sort of noon to midnight, on the 22nd. And then finally, in the upper left-hand corner, we have the full moon on the 29th. We end the month with a full moon. Mars and Saturn are sinking toward the sun, so we see them in the west just after sunset. I would go earlier in the month to see Mars and Saturn. We see it here fairly early in the month. The moon, Mars and Saturn, or really the moon and Mars, are shown here on the 18th of September. So the moon will guide you to Mars. Mars will be dimmer because we'll have all of that sky glow from the sun, all that light pollution. We have Venus and Jupiter shown here on the 6th, fairly close together. But Jupiter doesn't rise until a little bit after midnight at the beginning of the month. It rises about 11 p.m. at the end of the month. So Venus and Jupiter are very bright. The summer triangle is straight up overhead. It consists of Deneb in Cygnus, Vega in Lyra, and Altair in Aquila. So it's an asterism. It's out of 3 different constellations. But these are 3 really bright stars. Now, Cygnus is straight overhead. We have Albireo at the other end of Cygnus. Now this is at the foot of the cross, if you will, but really the head of the swan. And Albireo is an interesting star in and of itself. So if you look at it at higher magnification with a telescope, you'll see that it is really a double star with a gold star and a blue star. And remember here, it looks better in the telescope than on the TV screen. And that's basically what's up in the night sky for September 2012. Wherever you are, we have the sky every night. It's the greatest show, and it's free.